Okay, here we go. Continuing on with geometry, we're going to learn about 5 new pairs of angles. How many pairs of angles do we already have? Are there 5? What are they? What are our pairs of angles so far? Sorry? Linear pair? Adjacent? Vertical? No, that's a type of angle. Supplementary and complementary. Good. So we have 5 pairs of angles. And you can review those at your own time. By now, you pretty much have those burned into your brain. Today, we're going to get, I think, 5 more pairs. But these are special scenarios that we're going to meet using the fact that we're going to have some parallel lines. Okay? So, what are 3 possible ways for lines to interact? In other words, if you drew 2 lines on a piece of paper, how many different ways can you do that? Okay, one would be they intersect. Parallel, meaning they don't intersect. No, that doesn't count, but that's a good one. I don't know, I don't think you'll get the third one. Okay, so 1 is that they intersect, 2 is that they're parallel. Symbol for parallel, have we done that symbol yet? The 2 little lines next to each other? Okay? No. This is, the first 2 are what we're going to spend 99% of the time working on because it happens in a 2-dimensional space. No, that is a good answer. Maybe I should do 4. That is a good answer. But technically it says 2 lines can interact, so if it's the 2 lines, there wouldn't be the same line because that would only be 1 line. The third one is what's called skew. Now, the reason we don't talk about skew a lot is because it has to do with the 3-dimensional world. So if you look up here, for instance, if these are my lines, this would be intersecting, this would be parallel, and then all of a sudden skew looks like this. Okay. They're not intersecting, but they're also not parallel because we're doing a 3-dimensional thing. So it would look something like that. 2 different lines on 2 different planes that never intersect. But we're not going to deal with that a lot right now because we're just doing 2-dimensional stuff, not 3-dimensional stuff. Okay, so here's a little example, or a little picture, if you will. Danny, tell me what's happening in that picture. Give me some interesting stuff.
My FJ is going to plane, and my EG and EH are parallel.
How do you know they're parallel? They certainly look parallel. Are they?
The arrow.
Good. Yeah. You'll see, if you look closely, there's an extra set of arrowheads in the middle of the lines there. Those arrowheads denote in a picture that those lines are parallel. So Danny is correct. Those 2 lines are parallel, and then FJ passes through the plane, which is why we have that dashed area. We've talked about that already. What does the dashed area mean? Yeah, it's hidden underneath this 3-dimensional looking picture. Okay? We already talked about the parallel lines, Danny. Which lines are not intersecting?
Line JF and KH.
Jaguar, ferret, and kangaroo hippopotamus. Correct. And which lines are skew? Say that again.
They're going to be kangaroo, hippopotamus, ferret, and jaguar.
Correct. Okay. And then which lines intersect?
EG,
I'm sorry, what was that?
elephant, gorilla,
I love it. Yep.
ferret.
I said jaguar, but are you trying to change it up to another animal that begins with J?
Yep.
Anybody?
Jackrabbit.
Jackrabbit? That's kind of cheating, but that's okay, we'll take it. technically that would be an R for rabbit. You go with jackalope.
Jack-o'-lantern.
I'm sorry?
Jack-o'-lantern.
A jack-lantern?
Oh.
Oh, jack-o'-lantern.
Yeah.
Yeah, but that's not an animal, that's a plant. A jackal would be a possibility, yeah, but not a
It's a
jackal.
living shape.
It's a vegetable.
Jellyfish.
What? Jellyfish.
It's a carved pumpkin.
I understand what a jack-o'-lantern is, but we've got a theme going here.
It has
That's
eyes.
a-
You know what we could have said? I just thought of this. We could have said Jackson.
Jackson's a hero.
Well, he's not a vegetable. He's not a mineral. He's a living animal, right? He still fits the characterization, but it's technically a, yeah. But anyways, okay. Any problems? Good. What we want to care about from this point on is mainly the parallel and the intersecting. We're not going to do, like I said, we're not going to do a lot with skew lines. So don't freak out if you don't understand what skew lines are, because that's 3D stuff that we'll do later. Okay, now, we get this picture. You're going to get so tired of this picture that you're going to want to scream. I took two lines, those are the black ones, and I intersected them with a red line. That red line is called a transversal. You can see the definition up there. It's a line that intersects at least two other lines. Okay, so I called my transversal line T. It doesn't matter what you call it, I don't care. When you do that, you'll notice that 8 different angles are formed. And I numbered them 1, 2, 3, 4, 5, 6, 7, 8. Don't get in the habit of thinking it's always going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, we'll name those angles all kinds of different ways, but what you should realize is that there are 8 possible angles. Okay, based on that picture, Logan, are there any relationships between any of the angles in that picture?
Eight and 1 are equal. 8 and 1 are missing. Angles 4 and 2 add up to 180.
Say again?
Angles 4 and 2 add up to 180.
Perfect. Also known as?
Supplementary.
Good. Also known as?
Adjacent angles.
Also known as?
Non-adjacent.
No, you got one more.
Not complementary.
Okay, I'll give you that. Also, not a hippopotamus. Not a black hole in space. You see where I'm going with this?
Yeah.
Right? Not Taylor Swift. Okay.
Linear pair.
It's a linear pair, correct. Anything else, Logan? And by the way, we could also take that and say 1 and 2, 2 and, you said 2 and 4, right? We could also go 1 and 2, 1 and 3, 3 and 4, 5 and 6, 6 and 8, 8 and 7, 7 and 5. Okay, so we've got a bunch of linear pairs up there. Now notice, the 2 angles that he gave us, 2 and 4, are around the same point of intersection. Okay? Logan, anything else?
1 and 3 are supplementary.
Yeah, we did all those. Any other relationships? Juliana, what were you going to say?
1 and 4 is equal.
Good. What kind of angles are those? Vertical angles, correct. So we got a bunch of vertical angles up there too. 1 and 4 are vertical, 2 and 3, 6 and 7, 5 and 8. But again, all of those angles we've talked, those pairs of angles we've talked about already, and they all come from the same point of intersection. Okay? Both angles came from that point of intersection, or both angles came from that point of intersection. We want to change it up a little bit. We're going to start pairing up one angle from the first point of intersection and one angle from... It's like a magic finger. Huh. Around that point of intersection. Okay? There's our first one. Corresponding angles. They're called corresponding angles because they're in the same corresponding location around the points of intersection. So you'll notice my mooing cows are in the upper left-hand corner. The upper left-hand corner from the top point of intersection matches with the upper left-hand corner from the bottom point of intersection. Okay? Questions? Good, and I have a question for you, Ryan. Where are the other corresponding angles in that picture other than the mooing cows?
6 and 2,
Excellent, keep going.
7 and 3, and 8 and 4.
Sorry, I was drinking. Well done. Okay. 2 and 6 are both in the upper right-hand corner. 4 and 8 are lower right. 3 and 7, lower left. You're going to see that with these angle measures, again, mathematicians are lazy. We don't want to write out that big thing, so we're going to abbreviate it CORR. And in fact, you could get rid of that word and put in an angle symbol. Just to reference that. Okay? And that's exactly what Ryan just explained to us. Well done. Any questions so far? Okay, beautiful. Next pair. Now, let's make our lives a little bit easier. Instead of going home and memorizing things again, let's think about this logically. These are called corresponding angles because they're in the same corresponding location. Okay? These are alternate interior angles. Why are they called alternate interior angles? Because they're on alternate side of the transversal. One is on the left-hand side, one is on the right-hand side, and they're in the interior between the lines. Okay, so interior, inside. This is the interior here. This is the exterior. So those weird top hat looking stars are one pair of alternate interior angles. Liam, where's the other pair?
5 and 4.
Well done. Any others? No, just 2 pairs. Okay, so instead of just clicking on the next slide, let me ask you, Bill, where are the alternate exterior angles in that picture?
Two and 7.
Yes? And?
1 and 8.
Well done. Okay. Again, use the name of the angles to, instead of just memorizing, you've got this creepy unicorn turning and looking at you. If I could blow that up, it's one of the creepiest gifts I can find, that the unicorn looks at you like it's just going to suck the soul out of your body. But anyways, we're talking about angles that are on opposite sides of the transversal, okay, alternate sides of the transversal, and they're in the exterior. And as Bill said, we've got 1 and 8 and 2 and 7. Okay, so Lucy, if I was to say to you, same side interior angles, which ones would those be?
3 and 4 and 5 and 6.
No. You got to pick one from each point of intersection. So one from the top 4 and one from the bottom 4.
4 and 6 and 3 and 5.
Perfect. Okay. Again, use the name. Same side. On the same side of the transversal. In the interior. So the little swimming fishies are one pair, and as Lucy said, the other pair is 4 and 6. Which one didn't we name? No, what's my next pair of angles without looking ahead? That was good? Oh, you cheated. Anybody not look ahead and tell me the next pair of angles? Brandon?
Same side exterior.
Well done. Now notice, The first angles we started with, there were 4 pairs of corresponding angles. Everything else is 2 pairs. And again, we're using the KISS method. Keep it simple, stupid. Use the name of the angles to reference which ones you're talking about. What we've just done is simply identify the pairs of angles. We did not make any judgments about their relationship. We don't know that those 2 alligator angles are equal. We don't know if those 2 alligator angles are supplementary or complementary or whatever. We're just saying those 2 walking alligators are in the same side exterior angle location. Okay? So, yes, sir.
I have a question. So,
Certainly.
well, what would be like the relationship between 6 and 1?
Let me go back to one that's got 6. Oh, this one here? There isn't one. That's not a pair of angles we ever deal with. We'll talk about them later, but they don't get their own names. Great question. Okay, so let's go to this. And as I said, I'm going to change the name. So now I've just named the angles mouse jaw. Where are the corresponding angles, Zoe? Good start. Give me the other 3. Not to be confused with the killer. Perfect. Okay, good. Where are the alternate interior angles? Carly?
Oh, alternate interior for
Yep,
SJUE.
perfect. Alternate exterior. Lana?
W and O,
Yeah, and?
M and
Good. Same side interior. Michael?
SE and UJ.
Very nice. And last but not least, same side exterior angles. Luke?
A, W, M, A, O.
Well done. Okay. Any problems? Pretty easy? This is the audience participation part of the program. Pretty easy?
Yeah.
Okay, good. Please don't go home and memorize these. Use the names. Okay? Both ways. If I ask you where the alternate interior angles are, use the name. If I ask you what's the relationship between angle U and J, you can use the same idea. Well, they're on the same side of the transversal in the interior. Oh, that makes them SSIA angles. Okay, any problems before we move on? We're going to change one small thing now, and that is we're going to make the lines parallel. Okay, so everything we did up until this point was just 2 lines cut by a transversal. Now we're requiring that they're parallel. And as Danny pointed out earlier, all of a sudden we have those arrows there, so now we know that those lines are parallel. All right, let's go. Abby, you ready?
Sure.
I got some questions for you. What color would you like, first of all?
Purple.
I don't have purple. I got red, black, blue, or green.
Blue.
Blue. Prospect blue.
Okay.
Excellent. Hey, Abby, how big is angle 6?
65 degrees.
Tell me why.
Because they're vertical angles.
Okay, good. You know what? I'm not going to direct you. I'm just going to let you go. Give me some more angle measures.
Would 2 and 3 also be 65?
Would 2 and 3 also be 65?
Yes.
Okay. All that matters is we got the thumbs up from Danny in the back. Okay. Good. You got 4 of 8. Keep going. Busting out that calculator.
And then all the other ones are 115.
Sorry, I did math wrong. I'm not real strong on numbers. All the rest are 115. Do you all agree?
Yes.
Beautiful. This is going to be a cakewalk then. Notice, once I make the lines parallel and I cut them with a transversal, there's only 2 angle measures up there. 4 of them are 115, 4 of them are 65. Oh, also notice, 4 of them are acute, 4 of them are obtuse. And again, the KISS method. If Abby was to say to me, oh, I think angle 2 is 115, aside from laughing in her face, I would also ask her, well, Abby, isn't that an acute angle? How can it be 115? The answer is, it can't be. Okay, so we're good on this picture. Excellent, then the rest of this is going to be easy, because all we're going to do is we're going to go back through all those definitions that we did, and we're going to talk about what if the lines were parallel. Okay, so if you look at that little picture with the walking alligators, what if the lines were parallel? Would there all of a sudden be a relationship between those types of angles? Okay? Whoa, hold on, I gotta clean this mess up. What are we doing? Get out of here. Okay. I talked a little bit about it in the past about proving things. Instead of me just giving you stuff and then you go home and memorize it or learn it and then you puke it back to me, it's important that you understand how these things work. In order to do that, we're going to prove some things. But in order for all of this to work, we need to start somewhere. Like it says, we've got to start somewhere. So I'm going to talk a little bit about this, about a couple words on this screen. The first one I want to talk about is a postulate. Okay, that word postulate means that it is an assumption. It's something that I'm going to tell you is true, and you're going to have to trust me on it. We're not going to prove it. For a variety of reasons. We may not be able to prove it. It may take too much time to prove it. You may not have the math skills to prove it, so you're just going to have to trust me. There are tons of postulates in your life. Okay, we don't need to go into them, but for us, we're going to start with this as a postulate. So I'm telling you that when you have parallel lines cut by a transversal, the corresponding angles are always going to be equal. In the bottom right-hand corner is the word theorem. Theorem, by definition, is something that can be proved. Theorem. If I smack Riley's water cup, or Stanley, on the floor, water will spill. Can I prove that? I can't. But it can be proven, right? Okay. Another theorem. If I punch Jackson in the face, I will lose my job. Can we prove that? Right. What do I have to do? Punch him. Right. Okay, so these are theorems. They can be proven. Can you give me an example of a postulate that's not mathematical based? Something that you believe is true, but you can't prove it. I'm sorry? Perfect. Okay? This is a little awkward here, and I apologize ahead of time. We all know there's no such thing as Santa Claus, right? Of course it would be Jackson. Bad example. No, I mean Santa Claus is a theorem. We prove it every year. Santa Claus is a good guy. You are kidding, right? Huh? We're running out of here crying. Mom, they said it's cool that there's no Santa Claus. A lot of little kids believe in Santa Claus. Can you prove that Santa Claus exists? No, because Santa Claus, I mean, this is a kind of a weird postulate, because you could kind of take a kid to a store where there's a guy dressed up as a Santa Claus and go, hey, there's Santa Claus. Okay, then it becomes a theorem. Any other examples of postulates? Beautiful. Okay. Mermaids are real. We can't prove that. In order to prove that, we'd have to go through the entire ocean and eliminate everything to find that there's no mermaids. Oh, tooth fairy. Gotcha. Right. I mean, it seems like it would be a real thing, right? Your tooth falls out, you put it on your pillow. What's the going rate for the tooth fairy, by the way? $1 or $5? Okay. All right. Just wondering. Has anybody never gotten a tooth fairy at their house before? It's okay. All right, moving on. You got money? You never got money for a tooth? Candy? Well, that's kind of ironic, isn't it? The tooth falls out, you give them candy, which traditionally causes teeth to fall out. That's fun. Okay, anyways, so we're going to start with this idea. if we assume that that is true, which you're going to have to do in order to move forward, we know that anytime we talk about corresponding angles, they will always be congruent. Now we're going to use that to prove this. So now this is a theorem. When it's a theorem, you should not be happy just believing me. We can go and prove that this is true. Okay? So how do we prove it? Well, I'm going to introduce another angle here. I'm going to introduce an angle here. We'll call that angle 1. And then if I call that angle 1, I can now prove this theorem. So, what do we know about angles 1 and 3?
They're the same.
They're the same. Angle 1 is equal to angle 3. Why? What kind of angles are they?
Linear.
No. Vertical, correct. What do we know about angles 1 and 4 now?
They're the same.
They're the same. Why?
They're just similar.
What kind of angles are they? Corresponding. We just did that on the last slide, and that's why we had to assume the last slide. If angle 3 is equal to angle 1 and angle 4 is equal to angle 1, what does that tell you about angles 3 and 4?
Same.
They're the same. Done. That is a proof. Simple, clean, and to the point. It also works for any possible angle measures, because notice I didn't throw angles in there like we did on the last one when Abby helped us. We didn't say that that angle is 65 and then 115. We just said for all angles. This process continues through all the other theorems. And we can prove every one. We're not going to. They kind of become postulates, so you're going to have to trust me, especially since we only have 7 minutes left. But alternate interior angles, if the lines are parallel, will be congruent. Before I move to the next slide, next we're going to do alternate exterior angles. So let's make angle 1 and angle 7 there. What appears to be the relationship between angles 1 and 7? Those are same side exterior angles, correct. What's the relationship between them now? Go in. Yes. How do their measures compare? Perfect. They're supplementary. Okay. Let's put a 6 there. What's the relationship between angles 4 and 6? Go. Good. They're also supplementary. How about 7 and 8? What kind of angles? Yes, they're congruent. What pair of angles are they?
Alternate exterior.
Good. We've just done all the work. Okay, so same side interior angles. Oh, let me get rid of this mess. Stop it. Same side interior angles are supplementary. Keep it simple. Look at the two angles. One of them is acute, one of them is obtuse. They have to be supplementary. Same side exterior. One is acute, one is obtuse. They're going to be supplementary. Alternate exterior. One's obtuse, one's obtuse. They're going to be congruent. Okay, we'll save that in a second. So let's go all the way back to the one that Abby did for us. If I pick any angle in that picture and then randomly pick another angle, you've only got two relationships. What are they? Supplementary or? No. That's a pair, but what's their relationship? Congruent. That's it. There's no other possibilities. Okay, so let's not complicate things. Whether we're talking about angle pairs we've mentioned. So, Brandon, question for you. You brought this up earlier. How big is angle 1 if I know that that's 65? That's the pair you talked about, right? That doesn't have a name, but could you tell me what the relationship is?
Say that again?
What's the relationship between this angle and that angle?
We
Oh, we do know though. That's my point. Jackson,
Both add up to 180.
also known as?
Supplementary.
Good. Okay. Because there's no other possibilities. Again, acute, obtuse, can't be congruent, must be supplementary. Whoops. Okay, we got that. Are we good up until this point? Okay. Now, the only thing that's different about this is instead of just having any old random transversal run through there, I made it perpendicular. I don't want to beat a dead horse here. I think you can all see how big is this angle if it's perpendicular. How big is that angle? This one, this one, this one, this one, this one, and this one. They're all 90. Everything's perpendicular. One big happy right angle party. Still satisfies the previous conditions. I picked two angles at random. They can be either congruent or supplementary. These, however, happen to be both at the same time. Okay, now, in 3 minutes, I'll make this quick. You're going to start solving algebraic problems involving the stuff we've talked about already. I have some tips to help you. I think I included this, right? Okay, so I'll just click 4 times and we can read it together after I get this out of the way. Determine, when you're presented with a problem, look at the two angles that you're dealing with and ask yourself, which pair of angles am I talking about? They could be the 5 that we did a couple days ago. It could be the 5 that we did today. Then decide if you're going to set them equal to each other or add them up and set them equal to 180. In other words, are they equal or are they supplementary? Solve the equation. And then make sure step 4, make sure you plug it back in and answer the question. Sometimes I'll ask you all kinds of different things that aren't just what x is equal to. Okay? So, real quick here. What's the relationship between this angle and that angle? Danny. They are supplementary. Good. And just for the folks at home, what pair of angles are we talking about there? Beautiful. Same side exterior angle. So that's like a bonus question. But Danny, if you told me they're supplementary, right? What would you do with these two values then? Add them up and set them equal to 180, solve for x and solve. Hold on, I'm almost done. We get a value for x and I plug it back in. How do I use that information to find angle 4? Yeah, it's the same as 125, or it's supplementary to whatever value we get here. This process will repeat quite a bit. Okay, questions? I'll unlock the day 2 homework and we'll talk about that on Friday. There's a couple other examples. Oh, remind me. Wait. Sit down. This is important. On Friday, remind me to talk about crook problems. We didn't get to it and it's an important type of problem. Okay, because that would end the slideshow. I missed that and we only have 30 seconds left. And some of you have trouble with the idea of sitting down. So sit down. Sit down. Sit down. Sit down. Sit down. Have a good day. Leah, don't forget your calculator in the back.